what I would like to do over the next 10 or 15 minutes is give you, first of all, I'll give you an overview of the collaborations we already have at a European level and specifically with the Spanish level, and a little bit more about that collaboration we have with Tenalia. And then what I'd like to do is complement Jose's presentation on this look at sort of the different opportunities going forward at a European level, and then bring them to life with some of the economic benefits that could potentially be available specifically in wave and tidal streams. So in ocean energies, we describe it at a European level. So to begin with, as Max said, I lead the Policy and Innovation Group within the University of Edinburgh within our Institute for Energy Systems. Like Tenalia, we've run just over 20 EU projects over the past 10 years in ocean energy and some now in offshore wind. We have a group of 10 engineers and we work at the interface between technology development and policy development. So we understand the dynamics of innovation and how that could affect the policies that would be suitable to implement any of the challenges that we have predominantly at a technology level. So we have a range of services that we offer into European projects, predominantly techno-economic assessment, life cycle evaluation, optimization of technology and arrays, and then overall that strategic planning and road mapping in order to take the sector forward. The partners that we work with we'll work with technology developers themselves, we'll work with other research providers, both at a UK and European level, and with governments and trade associations as well, both in Europe and internationally. The projects that we have running currently, we've got 10 projects running currently. 6 of those projects have Spanish partners within them. So here on the left-hand side, you can see the projects there from ETEP Ocean through to DT Ocean to Floatant, which is our one floating offshore wind project. And we cover these projects at a number of levels. So we have projects that are for the coordination of the overall sector, such as the ETEP project, the Technology and Innovation Platform, funded by the Commission, and similarly with the European Energy Research Alliance. So those are projects that we have where we help use our work to influence the overall coordination of the sector at a European level, but then also projects such as the DT Ocean and Floatant, where we're then doing assessments, very detailed assessments of the technology and its cost and performance. And we find that balance of seeing the detail of the projects themselves, plus the bigger picture of what's happening with European strategy, very helpful to align ourselves with other projects. As Jose said, we have a collaboration agreement between the University of Edinburgh and with Tenalia, because we worked on European projects together for over 10 years. And so we put together a collaboration agreement to help enhance that collaboration that we had, where we will then each month we have a meeting where we discuss existing projects, discuss future projects, both domestically that are happening in each of our countries, and opportunities both at an EU and international level, looking for where there are opportunities for collaboration in the future. It's not essential that we collaborate. There are projects where we don't collaborate, but at least we discuss if there is an opportunity for collaboration, and we found this very helpful over the past 2 years since we've had this collaboration in place. Okay, so moving then to the study itself. This is a study that we've done within one of the European projects and one of actually the domestic projects as well, between Supergen in the UK and the European Technology and Innovation Platform at European level, where one of my colleagues, Charlotte Cochrane, who's done this analysis, looks at the GBA available from different deployment levels of ocean energy, so wave and tidal, both at a European and international level. For those of you not familiar with GBA, it's the gross value added, so it's looking at the value of goods and services produced in that country, so in this case wave and tidal, divided devices minus the raw materials that are already attributed to that product. And so it is the main metric that's used by government treasuries around the world in order to assess the value of a sector to a particular country or to a particular country's economy. So in this study, we'll look at the benefits to Europe as a whole. We don't do it, we don't drill down into the benefits of any one country, because the opportunity for like moving the supply chain between countries is based on the competition and the expertise in that particular country. That will change over time. But what we do is look at different levels of changing the levelized cost of energy and its and how that could reduce over time, combined with what we call the leakage rate, which is the supply chain capability that of the devices that are manufactured in Europe or deployed in Europe, how much of those deployed devices come from the European supply chain and how much of it is from imported products. And we look at the different levels that are available between those two main factors. So in order to start the study off, what we need is an assessment of what the levelized cost of energy is currently. And that's particularly hard to get consensus on between the wide range of devices, especially in the wave energy sector, where there's very little design consensus. And so what we've chosen to use is the set plan targets for ocean energy. So the set plan is the overall strategic energy technology plan for Europe to allow the integration of the overall energy mix. And they have plans, implementation plans, and targets for all of the different technologies within it, not only for ocean energy. And they have targets in place for €100 per megawatt hour and €150 per megawatt hour for tidal and wave respectively. And so that's what we've used as a baseline in order to try and, first of all, then predict the level of deployment that will happen at a European and international level. In order to do that, then we've worked with energy system modelers, both within the IEA, the International Energy Agency in Paris, and at the JRC, the Commission's modelling team in Edinburgh, outside Amsterdam, that look at that run the models that say, okay, at the different levels of competition between different technologies receiving a certain level of cost and performance, what will the deployment likely to be? And so we worked with these two teams, and we're very pleased that we've been able to bring these two teams together. I think, for one of the first times, especially within ocean energy, for sure, where these teams are working together using the very same input conditions. So you've got a like-for-like comparison between a European and an international level. And this is the two scenarios that we've investigated, and I'm sorry this slide is a little bit busy. First of all, we look at the left-hand side of the screen. We've looked at what the scenario would be if you achieve the set plan targets of 100 and 150 euros per megawatt hour for tidal and wave, and that would lead to a deployment of 60 gigawatts in Europe and nearly 200 gigawatts globally. And so that's our first scenario that we investigate. We then look what we've described as beyond the set plan, where the IEA have looked at saying, yes, we will take the set plan inputs at 2030, but then we will assume faster levels of innovation from 2040 to 2050. And this is part of an overall study that they've done alongside their annual energy technology perspectives report, where they look at this case of enhanced innovation for the clean energy sector. And in that case, then it's almost 300 gigawatts that will appear at an international level, and we've then modelled what will happen to the European share between 60 and 100 gigawatts. And so, although that's quite a lot of information to take in there, hopefully that will become clearer as I go through the deployment. To the left-hand side, achieving the set plan targets, and the right-hand side, achieving the set plan targets still in 2030, but then having enhanced innovation from that point onwards. So if we then look at in this case, this is the set plan targets, and so the base case of 100 and 150 euros. a megawatt hour for wave and tidal. And as you can see there, then you can see the trajectory in which the models are predicting the growth between sort of very minimal deployment levels at 2030, and then I would say almost exponentially ramping up to 2050. And here you can see we've split this out between what the deployment levels will be for, first of all, for wave, or in this case for tidal, at an EU level, and then you're also able to see what the deployment will be for tidal at an international level, and then similarly for wave, what the breakdown will be. And so interesting to see the one, I think, what the predicted exponential growth is. And I think that will be sort of very useful information for the supply chain policymakers funding the infrastructure in Europe to say what's the level of infrastructure and supply chain we need in order to deliver these targets, because they're not sort of a certainty. They need policies to support them. Now, if we then look at the faster innovation case from the International Energy Agency, where in this case, it's nearly 300 gigawatts globally. And again, you can see the splits between what the European and international market shares are between wave and tidal. In this case, we've run a scenario which is sitting at the same base case as before, that there are 60 gigawatts in Europe. And we've also done a sensitivity to then say, okay, what would then be the energy mix if the European supply chain was enhanced in order to have 100 gigawatts in Europe. And so those are the scenarios that we have in place for deployment. And what we've then done is then saying, okay, under those assumptions for deployment, then what would be the economic benefit to Europe under those cases? So we've then done the GVA analysis, and I've just put three of them here for clarity in the first instance. And so we've looked at that case where there is the global deployment in the FICs, the faster innovation case from the IEA, with 100 gigawatts in Europe, where you can see almost 120 billion of economic benefit to the European economy, dropping down to the base case of the set plan of around 70 billion. So very significant numbers, and very useful for policymakers to then say, okay, if this is the return, then how can I then think about going, first of all, if this is a return that's attractive compared to other sectors that they have available to them for low carbon options in their energy mix, then thinking, okay, how much money do I have to then spend on support policies, whether it's technology push or market pool, in order to allow this scenario to come to life, because it is just a scenario, and there will be supporting policies required in order to turn it into a reality. We've done, I've added in here some of the sensitivity that we've done. I won't go through these numbers, but it will be available to you in the slides, where I've broken down. First of all, I've added a couple of extra runs there of different sensitivities that we've done for deployment levels. But what I've also done, or I should say Charlotte has done, is then broken that down as to where the GVA share comes from, how much of it comes from European deployments, how much of that comes from international deployments. And there are further sensitivity that I don't have time to go into today, where we then also then adjust the market share that we have under sort of a Monte Carlo analysis for a range of market share conditions. And so hopefully that was useful for you. Hopefully that complements the presentation of the opportunities that are available in Europe. This has then added some information on the economic benefit associated with those opportunities. In this case, running with the set plan targets of 100 and 150 euros for tidal and wave. Then bringing that into, if you do achieve those figures, then feeding them into the market allocation models, both at an EU level with the JRC and an international level through the International Energy Agency's modelling. But what to remember is these are models; they're not predictions of what the future will definitely be. They are predictions of what the future could be, and there will still be challenges associated with that. So it gives an indication of what could be a future scenario. scenario and what could be an economic return, but there will still be challenges to face with regard to making sure that there are improvements in cost, performance, and reliability of the technologies, and thinking then what are the policies to enable these future scenarios to become a future reality. So I'll finish there, but thanks very much for your attention. And I look forward to any questions now or in the round table later this afternoon.